In this video, we are first going to look at equations that have squares and square roots, and then after that we'll look at equations with cubes and cube roots. So to start with, this is the graph of the function y equals x squared, and we're going to use this graph to help us solve these two equations. So this first one, x squared equals 4, we're trying to find values of x that will make the y value in this equation equal to 4. So on the graph, a y value of 4, here on the y-axis, and so if I draw a line here at a y value of 4, notice it crosses the graph twice, here at -2 and here at +2. These are both solutions to this equation. X equals -2 and x equals +2. If you were solving this equation using inverse operations, so I'm going to write that over here, x squared equals 4. To get x by itself, you would take the square root of both sides of the equation. The square root of x squared is just x. And the square root of 4 is 2 or -2. And so you could write that as plus or minus 2. So the two ways that you can write the solutions, you can either write them separately, -2 and +2, or you can write them with a plus or a minus. But this equation does have two solutions. The next equation, x squared equals -4. So we're trying to find values of x that make the y value equal -4. But notice on the graph, if I try to find a y value of -4, that's actually below my graph here. The graph doesn't go this low. The graph only has positive y values. So this equation has no solution. There is no point on this graph that has a y value of -4. So there is no value of x that will make this equation true. There's no number that you could square and get a negative number. So in summary, for an x squared equation, if x squared is equal to a positive number, any positive number, such as 4, there are two solutions to that equation. If x squared is equal to a negative number, then there are no solutions to that equation. So then let's look next at the square root function. So this is the graph of y equals the square root of x. And again, we'll use the graph to solve these equations. So for the first one, we're trying to find x values that make the y value equal to 3. So on our graph, here's a y value of 3 on the y-axis, and I'm going to draw a line there. And I'm going to look to see where it touches this graph, and it touches right there. When y is 3, the x value is 9. So the solution to this equation is x equals 9. And that's the only solution. That's the only time when this line at 3 crosses through our pink graph. If we solved this equation using algebra, using inverse operations, so square root of x equals 3, you would take the squared of both sides, raise both sides to the second power, and you would get x equals 9. You would just get this one solution. Now, this next equation, the square root of x equals -3. So I need to find a y value of -3 and figure out what the x value is at that point. But notice on my graph, just like before, my graph doesn't go down to -3. This graph here doesn't have any points when y is -3. So this equation has no solution. There is no value of x that has an output or a y value of -3. So if you have an equation with the square root of x is equal to a positive number, any positive number, there will be one solution to that equation. If the square root of x is equal to any negative number, then there are no solutions to that equation. So let's look next at cubes and cube root functions. So we'll start with the function y equals x cubed, or x to the third power, and we'll solve these two equations using the graph. So x cubed equals positive 8. So we want to find the y value of 8 and figure out the x value at that point. So on the graph, here's a y value of 8 at the very top of my graph here. I actually kind of cut it off. But that crosses or touches my graph, this x cubed graph right here, when x is 2. And that's the only time. So even if I extended this line at 8 out, this is the only point where this line at 8 intersects our graph. And so there is just one solution to this equation when x equals 2. Then the next equation, x cubed equals negative 8. So before, with the squares and square roots, they could not equal a negative number. But let's see about with the cube, and then we'll do the cube root. So if we look on our graph for a y value of negative 8, now again, I kind of cut it off down here, but notice that our graph is going to have a point down here at negative 8, just below, right? This is continuing down this direction. So if I draw a line down here at where negative 8 would be if I hadn't cut it off, then our graph has one point right there. So there is one solution to this equation. It has a solution. When y is negative 8, the x value is negative 2. So unlike a square and a square root function, a cubed function can equal a negative number. If you multiplied negative 2 times negative 2 times negative 2, you would get negative 8. So with a cubed equation, if you have x cubed equal to a positive or a negative number, there will be one solution to that equation. Now, what about a cubed root function? So here's the graph of a cubed root function, y equals the cubed root of x. Notice it's kind of just a sideways version of that graph we looked at up there, x cubed. So to solve these equations, find a y value of 2 and figure out its x value. So a y value of 2 is here. So I'm going to draw a line all the way across, and it touches my graph right here at 8. So when y is 2, x is equal to 8. And so that is the one solution to this equation. The cubed root of 8 is equal to 2. Then, is there a solution for the cubed root of x equals negative 2? Well, negative 2 on the y-axis is here. And it crosses our graph just one time right here at negative 8. So this equation does have one solution. X is equal to negative 8. So, just like with an x cubed function, a cubed root of x function, if it equals a positive or a negative number, there will be one solution. So, cubes and cube roots, whether they equal positive numbers or negative numbers, will always have one solution. Whereas square and square root equations, they may have two solutions, they may have no solutions, or they may have one solution.